everybody's stuck. That's fine. We can talk about that. They're going to have a growth mindset today, and we're going to grow our brain. If you're stuck, just tell me you're stuck and we can move on and figure it out. All right, I got one answer.
I've never understood these problems.
Okay.
There's the,
Do you remember?
I've never understood that.
Do you remember the formula we talked about last Friday? Told you to write down the formula if you didn't know it.
Isn't it base 1 plus base 2 times width and height?
Height times, remember I had to make I put two trapezoids together to make the parallelogram, so it's going to be times 1/2. Okay, we're a bit confused, that's okay. All right, let's go ahead and talk about it. So if you remember back to last week when we figured out the formula, we added another trapezoid, an identical trapezoid onto it. And we discovered that the formula was going to be the area equals 1/2, because we made two trapezoids, times the height times base 1 plus base 2. Okay, you were right, Jahan. All right, so let's plug in. A equals 1/2. Okay, what's the height?
16.
16. What is one of the bases? It doesn't matter which base we start with. Okay,
17.
the bases are always parallel to each other.
Seventeen.
17. Okay,
26.
let's see. Jahan, can I make you a co-host so you can let people in? Do you know how to do that?
I think I'll try to figure it out.
Okay.
I've been doing it. That's what I've been doing.
Oh, you've been doing it for me? Okay, thanks.
Yeah, I was doing it.
Okay, one of you do it. All right, so base is going to be 39 plus 17. All right, order of operations says we do what's inside the parentheses first. So 39 plus 17 is 56. Okay, so we have 16 times 1/2. Half of 16 is 1/2 times 16 is 8 times 56. 8 times 6 is 48. Carry the 4. So we've got 448 feet squared. Okay?
Oh, okay, now I understand how to use the
Okay,
16.
so write this equation down somewhere where you can find it. You are going to need that when you take the benchmark next week. Okay, there will be trapezoids on the benchmark, and you'll need to know how to find the area. Okay, questions you have for me? Does everybody have the formula written down? You can always Google it as well.
No, I'm writing it down right now.
Okay, 1/2 the height times the sum of the two bases, base 1 and base 2. All right, we good? Can I erase? Can I erase? Going to erase. All right, so we watched the video on introducing graphs of proportional relationships. It was lesson 10. Our learning goal is let's see how graphs of proportional relationships differ from graphs of other relationships. By the end of today, I know that the graphs of proportional relationships lie on a line that goes through 0, 0. And what is 0, 0 called on a coordinate plane?
Point of origin.
Very good. Okay. What have you noticed about the graphs of proportional relationships? What did you notice when we did the activities? What did you...
the proportional, they make a straight line.
It made a straight line, and we call that linear. What else? The t-shirt problem. What else did that graph look like? It was in a straight line. All the points were in a straight line, as was the blueberry one in the summary. Did it go through the point of origin? Yes.
Yes.
Okay. Do you think this is true for all graphs of a proportional relationship? And that would be yes. Okay. Key points. On a graph, it makes a straight line. It is linear. If you want to write this down, it might be a good idea. It travels through the origin. The origin is the point 0, 0. If you want to screenshot this, write it down. This is your takeaway for graphs. It's also in the summary. All right, anybody need more time? All right, let's start with the practice problems. Which graphs could represent a proportional relationship? So remember, we are looking for 1, is it linear? And 2, does it go through the point of origin? So let's look at A. Is it linear?
Yes.
Okay. Does it go through the point of origin?
Yes.
Yes, so this one is proportional. All right, let's look at B. Is it linear?
No.
No, so that one is not proportional. We don't even have to go any further. It does go through the point of origin, but it's not linear. All right, C. Is it linear?
Yes.
Does it go through the point of origin?
Yes.
So that one is proportional. D. Is it linear?
No. Well, yes, it is.
It's straight line,
To the point.
but does it go through the point of origin?
No.
No, so it is not. So the correct answer for number 1 is A and C. Okay, questions? Can I erase? All right. Problem 2, a lemonade recipe calls for 1/4 cup of lemon juice for every cup of water. Use the table to answer these questions. What does X represent? What does this 1 under the X represent? What do you think? When we have 1/4 Y, we have 1 X. What do you think the X represents? Is it the
Cups of water.
water? So X is water. So what is Y?
Cups of
Lemon juice, okay. And I think both of them are in cups, right? Okay. So, third question is there a proportional relationship between X and Y? Well, when we're given a table, how do we find that?
We look for what 1 is.
Okay, but we need to see if they all are first. Okay, wherever X is 1, that will be the COP if it's in a proportional relationship. All right, so we do that by doing our Y over X and seeing if our quotients, our answers, are all the same number. So 1/4 divided by 1 is 1/4. 1/2 divided by 2 is the same thing as 1/2 times 2 over 1. Nope. What did I forget to do? Forgot to do the reciprocal, right? So that equals 1/4. Okay. 3/4 divided by 3 gives me 3/4 times 1/3. Oh, does that give me 1/4? Okay, 1/4 is 1/4. This is 5/4 divided by 5, which is 5/4 times 1/5. Those cancel, so that gives me 1/4. And this is 3/4, so is that right? 3, 2, 3. 3 halves times 1/6. That cancels, that gives me 2, that cancels, gives me 1. Oh, I got 1/4. All right, so is it proportional?
Yes.
Okay. What would the equation be?
Y equals 1/4 x.
There we go. All right, now let's graph it. Our point of origin is right here, so that's 0, 0. Our x-axis is water in cups. We always have to label. Okay. Our y-axis is lemon juice. And that's also in cups. All right, so we're going to do 1, 1/4. 1, 1/4 is about right there. 2, 1/2. 2, 1/2 is about right there. 3, 3/4. You know what we're going to do? This is too small. So we're going to make this 1/4, 1/2. We're going to make these by fourths and these by ones. Okay, so 1, 1/4, 2, 1/2, 3, 3/4, 4, 5/4, 6, right there. All right, what do you notice?
It's linear and it starts from the points of origin.
Okay, so, and we know it's proportional because we tested it already. But does the graph meet the requirements for being a proportional graph? Yes. Okay. Questions you have for me? All right, who needs more time? All right. On to question 3. Decide whether each table could represent a proportional relationship. If it is, then what would the COP be? Okay, how do we determine if a table is proportional? How do we determine if there's a proportional relationship between the width of a photo and the height of a photo?
Y over X.
Thank you. So we're going to call this our X and this is our Y. We're taking the quotient of the two. So this ends up being 3/2. This ends up being 6/4. Does that reduce to 3/2? Yep. Okay. This ends up being 7/5. Does that reduce to 3/2?
Yes.
All right, 3/2 is 1.5. Take out your calculators. Do 7 divided by 5. Do I get 1.5?
It's 1.4.
1.4. Is this proportional?
No.
No. All right, there's A. Anybody need more time? Anybody got a question? Okay, let's do B. Now we're looking at the height of a lighthouse and the distance it can be seen. How many of you think that should be proportional? I think it should be. Let's see if it is. All right, so we've got 6 divided by 20. So take out your calculators. What is 6 divided by 20? Okay. Then we have 9 divided by 45. Is it proportional? Do we have the same quotient? No, so we don't have a COP. So this one is also no. Questions you have for me? Who needs more time? All right. Question 4, select all the pieces of information that would tell you X and Y have a proportional relationship. Let Y represent the distance between a rock and a turtle's current position in meters. So we got a rock and we got a turtle. Okay, there's our turtle. There's our rock. The number of minutes the turtle has been traveling. Okay, is A proportional? Is Y equals 3x proportional?
Yes.
Yes.
Yes, why?
Because it's in the form of y equals kx.
Awesome, Jahan, very good. Okay, after 4 minutes, the turtle has walked 12 feet away from the rock. Do we know if that's all we know? Do we know it's proportional? Do we know he's walking at a constant speed?
No.
No, we do not. We're not given enough information to know that. The turtle walks for a bit, then stops for a minute before walking again. Is that going to give us a proportional relationship?
No.
No, because he's got time that he stopped walking. Okay? The turtle walks away from the rock at a constant rate.
Yes.
Yes, that word right there. Or those words. Okay? Questions you have for me? That one was pretty easy, wasn't it? All right. Who needs more time? Okay. What does the graph of a proportional relationship look like? Write it in the chat. I want everybody to write in the chat. What does the graph of a proportional relationship look like? What does the graph look like, Peyton? Not what does a table look like. What would a graph look like to be a proportional relationship? Okay, I've got some I don't knows. All right, let's go back. Did we determine that this was a proportional relationship with the lemon juice and the cups?
Yes.
In the table. We did that and we found the COP was 1/4, right? When we did Y over X, we got 1/4 for every single one of these. So from a table, that's how you tell. From a graph, we're going to graph this. So this is 1, 2, 3, 4, 5, and 6. And this is going to be our x-axis, and we said the x-axis was water in cups. And then our y-axis, you told me, was lemon juice in cups. And we're going to make each one of these 1/4. So I've got some room. Okay? And there's 0, 0. Except I don't want to graph 0, 0 because I'm not given 0, 0. All right, I'm going to graph 1, 1/4. 1, 1/4. 2, 1/2. 3, 3/4. 4, 1. This is 1 right here. 5, 1 1/4. 6, 1 1/2. All right, look at the graph. Tell me about what you see in the graph.
It's linear.
It's linear. That means it's in a line. And what else? If I was to draw this, would it go through 0, 0? Yes. And does that make sense? If I have 0 cups of water, how much lemon juice am I going to put in it?
0.
0 cups of lemon juice. Okay, so back to that last question, what does a graph look like if it is proportional? It's linear,
And plus in the place of origin.
and it goes through the point of origin, which is 0, 0. Okay, any other questions you have for me? All right, so tomorrow you will have, I believe you have a quizzes tomorrow. No, you have the card sort, which you will enter your answers on Google, a Google form to check it. And then I do believe you have a quizzes to do. Okay? All right, so you have a good afternoon, and I'll see you no, I won't see you tomorrow. I'll see you on Thursday.
Bye.
Bye.